Hey there kids, it's time for another math video. This is for Eureka Math, grade 5, module 3, lesson 5, homework. And hopefully you already watched the problem set video. Hopefully you completed your Learn book so you know what you're doing. And hopefully you saw that the objective at the bottom is to subtract fractions with unlike units using the strategy of creating equivalent fractions. So it's really just the strategy of creating that equivalent fraction that we're going to be applying from the first 4 lessons. And then we're going to take away from our whole. The whole is always that first number, so you have to be really careful with your models not to shift those 2 numbers around. Can't do that. It's not the commutative property or associative. Those don't work with subtraction. So let's jump right in. And again, hopefully you already did your homework and you're just checking it now. The picture below shows 3/4 of the rectangle shaded. Use the picture to show how to create an equivalent fraction for 3/4 and then subtract 1/3. And the first thing I have to point out is that after all the lessons where they set everything up with this vertical first, and then the second one we have our shading going horizontally, then they give you this, and they do horizontal shading on the first one. So super annoying that they switch it up, but it actually is going to show you a nice, easy thing that you can have them going either direction. It really doesn't matter. We're just trying for consistency. So we need to, first of all, make a fraction model for our 1/3 because we already have our 3/4. So we're going to take away from that our fraction model. Now for this one, I'm going to go ahead and do the vertical so you can see the difference. So make your, if you didn't already, or at least look for 1/3. Now if you did yours horizontally, that's totally fine. It doesn't matter which way it's going. It really doesn't. What matters is that you're going to lay the pieces over from the other fractions denominator onto what you make. So since we have 4ths here, I need to lay the 3rds over this one. And since I have 1/3 here, I need to lay the 4ths over this model. And so once you do that, then you've got your equivalents, the equivalent numbers that we're going to use, which we know now are the 12ths, and we're going to take away 12ths. And so how many 12ths did you create when you laid over the 3rds onto the 4ths? Well, remember the cross multiplication. Now we have 9 that are shaded on our first, the whole, the first number. And then we have 1, 2, 3, 4. 4 times 1 is 4. And so that second fraction should have 4/12. Do your subtraction, get your 5/12. And so that's how you create the equivalent fraction and do the subtraction. Hopefully you got 5/12 because that's how you want to do that one. Now remember with subtraction, if you do have a colored pen or pencil, you can take your 1, 2, 3, 4 pieces and cross them out 1, 2, 3, 4, and then count what's left just so you can be sure you're doing this the correct way. 1, 2, 3, 4, 5 is what you have left after you have taken away those 4. So that's why it's really important that you get this whole or keep the whole first, because all you have is what is in this first fraction. Then you're taking away from that. Very, very important concept right there. Okay, so if we're going to find the difference of these, if you want to make a little section for yourself to keep your work neat, that is advisable. Find the difference. Use a rectangular fraction model to find the common denominator since we have different numbers. Simplify your answer if possible. Now I showed you on the problem set video, if you go watch that one, how to make models that are so much easier than what the book gives you. So for consistency with the book, I'll show you the 18, and then I'll try to show you real quick how to do a simple model. So we have 5/6, cut it in half, and then 3 on the left and 3 on the right, and 5 of them are shaded. And then from that, we're going to subtract 1/3. But we can't do that because 3rds and 6ths are not compatible. They're not the same. So the book says, hey, let's take our thirds and lay them over the top, and then take your sixths, again, split it in half, and then for each half, you should have 3 on the left, 3 on the right. Now that's going to give you 18ths here and here. So now we can do this subtraction once we figure out what our numerators are. So since I had 5 originally, it's 5 now multiplied 3 times, which gives you that 15 that are shaded. And since we had 1 originally, but now it's 1 6 times separated, that's how you know to get the 6 for your second fraction. Now we're going to take that away and you get 9/18, and it says simplify your answer if possible. And I hope your teachers are talking about the relationship between the top and the bottom number, because what you want to do when you simplify is to take your 9/18 or whatever you have and find a common divisor, a number that would divide evenly into both of those. And I would say 9 can divide evenly into both of those, so that you end up with 1/2. So I say, look at the 9 and the 18, and I say, what's the relationship between the 9 and the 18? And my students say, well, this is times 2. This is doubled on the bottom. So I have a video, Mrs. Setness's rules for simplifying fractions. Go watch that. This is rule number 1. Look for doubles. Doubles are what I call the doubled from the top to the bottom. They're always equal to 1/2 in one step. If you simply divide them both by the top number, then you get 1/2. So what was I talking about with the simple model? This is on my problem set video. If you already have 5/6, and if you recognize that 6 is a multiple of 3. So here are my models again. Instead of just laying over like they're telling you to with the book, all I need is to make this model into sixths. So I can do it this way, or I could simply cross it over. All I need is a total of 6 pieces. And so this has 5/6 already, so I don't change it. And then I can take away 2/6 and end up with 3/6, which is then able to be simplified in one step by dividing by 3. And again, it's doubled. It's doubled from the top to the bottom. So they're both equal to 1/2. This is the way the book is teaching us here in this lesson, because they just, I don't know, they're trying to be consistent. Anyway, let's move on to the next one. 2/3 minus 1/2. So you should have your models already. Now you need to take the halves and lay it over, take the thirds and lay it over, so that now we have equivalent pieces. It has made sixths on both sides. How many are shaded here? 2 times 2 is 4. How many are shaded here? 3 times 1 is 3. 4 minus 3 is 1. And this is simplest form already. When you have a 1 on the top, you cannot simplify those any lower. 1 is the lowest number for your fractions. Okay, and then for this one, see, I wish I could just make always the simple models and use the lowest form. But we're going to make our sixths here. Shade 5. And then we have 1/4. Shade 1 out of 4. And when you take your fourths and take your sixths and lay them over each other, we're going to have fourths here. And we're going to have sixths here. Again, it's not art class, it's math class. So if it's not perfect, don't cry, don't stress. And now you know that you have 24 pieces in both. And you have 4 times 5 for 20 pieces here, and 6 times 1 for 6 pieces here. Do the subtraction. End up with 14/24. And please know that for Mrs. Setness's rules of simplifying, this is rule 2. Both numbers are even, which means if you don't know any other number to divide with, start dividing both the top and the bottom by 2. because we can have fewer pieces by dividing by 2. 14 divided by 2 is 7, and 24 divided by 2 is 12, which gives us our simplest form fraction right here. So we were able to simplify on that one like it says. 4/5 on the next one. Now when it's an odd number, you just kind of have to eyeball it and think, I need 4 lines within this to make the 5 sections. Shade 4. From that, we're going to subtract our 1/2. I always like to make that second one horizontal. And then we're going to lay over the pieces. Halves here, fifths here. Now you know you should have 10 pieces on each. This is my fraction, this is my subtraction, this is the fraction. Tenths is our denominator. How many pieces are shaded? Well, it's 2 times 4 for 8. It's 5 times 1 for 5. Do the subtraction and get 3/10. Okay, that's simplest form, so we're going to leave it and move on. All right, the last two with just the math without the word problems. 2/3 minus 2/5. 2 out of 3 sections should be shaded. Minus 2/5. I need 5 sections. 2 of them should be shaded. We need to lay over the pieces, so I've got fifths that I need to stripe on the first and thirds that I need to stripe on the second. That gives us 15ths on both of them, and now we can take them away. After I get my numerators, 5 times 2 shows me 10, 3 times 2 shows me 6, 10 minus 6 is 4 15ths. There is nothing that I can do to simplify that because there's no common divisor for both of those numbers. 5/7. 1, 2, 3, 4, 5, 6, 7. Shade 5, 3, 4, 5. Make sure that 2 are not shaded. And then thirds. 2 should be shaded. So we're taking away more than just ones on the top now. So I've got thirds that I need to lay over my sevenths, creating 21 pieces, and sevenths that I need to lay across the thirds. 4, 5, and split the last for 6, 7. Again, creating 21 pieces. 7 times 3 is 21. In the first model, and it has to be here, when you do your cross multiplying, you have to make sure that you're putting the right numerator with the right fraction model. So 3 times 5 is 15. Double check that you're multiplying 5 here 3 times and that 15 goes here. This model goes with this fraction and this fraction. Then with this one, okay, we're moving it over here. I had 2 pieces before, but 2 times 7 is 14. The second fraction has to be here so that we're taking away the 14/21 from the 15. And you get your 1/21, and that's as low as we can go because remember, if you have a 1 on top, you can't simplify that anymore. Okay, next one, we've got a word problem. Robin used 1/4 of a pound of butter to make a cake. Before she started, she had 7/8 pound or 7/8 of a pound of butter. How much butter did Robin have when she was done baking? So she starts with this. Now this is really key. You have to look at, sure they gave you this, but it's saying this is what she used. Read these problems carefully. Before she started, she had this. Basically what they're saying is, when she started, she had this. So how much butter did she have when she was done? Give your answer as a fraction of a pound. That means you have to write something too. Okay, so 7/8 is what she has in the beginning. This number has to come first. From that, we're going to remove what she used with the baking the cake. Okay, so make your model. Woo, that's a crazy one. Eighths are going to be divided into first 4 pieces and then split each of the 4. Okay, they're all shaded except one. So this is what 7/8 looks like. And on this one, I'm going to do my fourths right here. And we have 1/4 that's used. Now, I'm not going to make 32 pieces. I'm just not. I'm going to show you using the other strategy that I showed you on the other side. If I have 2 different numbers, and this is times 1 right here, I want to know how to have a simpler model and the lowest common denominator. 4 times 2 is 8. If I have a number in common, by George, I'm going to use it. If you want to make your model look like this so that you can see how many eighths now that they actually have equal pieces, you don't have to change 7/8 at all. You simply change your second fraction so that you have 2/8. And then you have a much, much easier time with your model. So 7 minus 2 is 5, and that's your simplest form. If I was to create an equivalent fraction, let's say you did this and you want to check your work, and I've got 1/4, and this is my subtraction problem. Okay, if I was going to multiply by the other, actually I'm going to set it up the other way. If I was going to multiply this just like this, okay, you know that what we've been doing is multiplying these two. You know that, right? I keep saying, well, you multiply these two. You multiply this by the top. There's your cross multiplying. You multiply this one up here, and then you can do your subtraction. But what happens is you end up having something that needs to be simplified. And so you have to have another step. You have to find a common divisor. So a number that goes into both. Now these are even, you could use 2, but there's also something that you can use that's higher. You want to use the greatest common factor. And I know that 4 is a number that I could divide both of these by, and I would get my simplified fraction that I got with my first model and my lowest common denominator that I used right from the get-go. So if you did it this way, your numbers would look like this. And if you see that you can use a lower common denominator instead of 32, by all means, use it. Could you have used 16? Yes, you could have, and you would get different numbers even still. Okay, and so the last problem, oh, sorry, I didn't even write my final answer. How much butter did she have when she was done baking? She had 5/8 pound lb of butter left. Okay, there you go. There's your statement. Okay, moving on. Katrina needs 3/5 kilogram of flour for a recipe. You know, I have to say, fractions and baking go together hand in hand. If you want to learn how to cook, you have to understand fractions. You're going to be multiplying and dividing recipes all the time, so let's really pay attention here. Katrina needs 3/5 kilogram of flour for a recipe. Her mother has 3/7 kilogram of flour in her pantry. Is this enough flour for the recipe? If not, how much more will she need? So basically, I need to find the difference between these two, and I need to have a common denominator, because right now they don't have common denominators. So if I said, okay, which one's greater? If I start with this one, 3/5, and I try to take away my 3/7, let's make the models and see what's happening here. Okay, she needs this, and her mom has this. She has this. So if I was to make 3/5, my first model would look something like that. And I'm going to take away my sevenths. And my second model would look something like 3, 4, 5, 6, 7. 3 of these. Now, if your model isn't, super great, like mine isn't that great, then sometimes it's hard to tell, like, which one's bigger because, well, we need this, but we have this. Is that the same amount? So we're going to take our sevenths and lay them over the first model, 6, 7, and take our fifths and lay them over this model, 3, 4, 5, and now I have created an equivalent denominator of 35 pieces. Go ahead and count them. Hopefully you did it right. If you lay sevenths over 5, you get 35. If you lay fifths over sevenths, you get 35, and that's the total number of pieces in the whole. But how many pieces are in this one? Well, 7 times 3 is 21. You can count them if you want. And 5 times 3 is 15. Now this again is what she needs, and this is what she has. So when you see that she needs a greater amount than she has, then what we're finding is how much more she still would need. So how much more will she need? She's going to be short. She will not have enough, and you need to write that. Okay? And then what is the difference? Well, if you do the subtraction, you'll get 6/35 as the difference. And so she will not have enough. She needs 6/35 kilogram more flour for her recipe. Okay? And so if you get all that, you can see how to do this problem. Anyway, I hope this video is helpful. There are no other questions. Click subscribe, come back again, and you'll get a lot more math help. So we'll see you on the next video. Bye for now.